Good evening, ladies and gentlemen. Welcome to tonight's Gateway to the Stars program. We have an exciting schedule of events set up for you tonight. Our first program is going to be with Mr. Ken Porter, who is a retired educator and reenactor with the Missouri Department of Conservation, and he is going to talk about finding your way with Lewis and Clark. Basically, how Lewis and Clark made their way to the Pacific Ocean, the instruments and techniques that they used to create their map and make it all the way to the Pacific Ocean. That'll be followed by my presentation, which is going to be a tour of the night sky, virtual stargazing at the Gateway Arch, following Mr. Porter's presentation. And then lastly, we will have hopefully live video footage of the moon taken by an amateur astronomer with the St. Louis Astronomical Society. So we hope you enjoy tonight's event, and we will get started now.
Hello, I'm Ken Porter. Today I'm going to be talking to you about the Lewis and Clark expedition and their making of maps to the western United States. I'm dressed as an 1803 military private. The weapon I have here with me is one of the issue weapons for the expedition. This is an 1803 Harper's Ferry rifle, 54 caliber. This is the Lewis and Clark grocery store. There were no McDonald's or anything else between here and the Pacific Ocean in 1803. If they didn't trade for it or shoot it or catch it on a hook, they didn't eat. So this was a vital piece of equipment for them. This is the standard military uniform of the day. This, starting off here, is my Class A cover. This is what I would use for parades and fancy occasions. Later in the program, I'll show you the fatigue cap. You'll notice the jacket is nice and colorful, but the rest of the uniform is white. And nowadays, everybody's uniform is camouflaged. But back then, the country was so poor, they could not afford to have colored uniforms. So they wore white uniforms. And this was not a group of shaggy-faced mountain men going west. It was required everybody shave every 3 days, and you had to get a haircut every month, even out in the wilderness. That we would divide up into teams, and because my brother was also on the trip, we were a team, would cut each other's hair, and we would shave each other. So you wanted to be very careful shaving your partner, because if you were a little rough with him, when it was his turn to shave you, he might be rough with you. Okay, so this was a very well organized expedition, and that's one of the reasons they were able to do all the mapping, is because they had to be able to coordinate with each other. As I said, the Lewis and Clark expedition was a military expedition headed by two captains. They left from Fort Dubois, which was at the confluence of the Missouri and the Mississippi rivers. The whole expedition was started by President Thomas Jefferson. Thomas Jefferson had been interested in the western United States for most of his life. In fact, Thomas Jefferson had one of the best libraries in the country, and many of his books were on the western United States. Unfortunately, at that time, there were some misconceptions about what was in the western United States. Jefferson actually believed that it might be possible to find mastodons, which were in the area. If you go just south of here, down Highway 55, you go to Mastodon State Park, where we have the bones of the mastodons who used to live here. So they did used to live here, but there were no live ones left for the expedition. He also thought there might be the giant ground sloth. The giant ground sloth found bones, but that's it. they thought there might be a mountain of salt. They didn't come close to finding a mountain of salt, but that was one of the things that was talked about. One of the other major things Thomas Jefferson thought they might run across were Welsh Indians. Expeditions had gone out previously looking for the blue-eyed Welsh Indians, and they never did find any of those. Every time they got to a new tribe on the Missouri River, they'd ask them about the Welsh Indians, and the tribes would say, "Oh, they're beyond the next tribe up the river." And they kept going up the river and they never found them. The other thing that Lewis and Clark were supposed to be looking for, and probably the most important part, was an all-water route to the Pacific Ocean. From an economic standpoint, this would have been fantastic. It's a long trip around South America to get to the Pacific Ocean. That was long before the Panama Canal. And so it took a long time to get around there. And the Northwest, Oregon, Washington, had a great fur industry. Originally, Thomas Jefferson approached George Rogers Clark, Hannibal of the West, hero of the American Revolution, to head an expedition to the West. And this was before the Louisiana Purchase. They were going to go on a scientific expedition that would have been theoretically all civilian, but obviously with George Rogers Clark leading it, it wouldn't be civilian. Strangely, George Rogers Clark is the brother, the older brother of Clark on the expedition. And in fact, Clark studied his surveying techniques and map making from his brother, George Rogers Clark. That there's in existence a textbook on surveying that has notes by both the Clark brothers in it. While they were working on getting an expedition put together and not having a lot of luck, a strange thing happened. The Louisiana Territory was originally French, but after the French lost a major war back in 1763, the Peace of Paris gave the Louisiana Territory to Spain as reparations. Well, after Napoleon got in there, he convinced the Spanish to repatriate the Louisiana Territory to France because he was trying to set up a Western Hemisphere empire. He was going to grow sugar, the sugar cane, down in the Caribbean, and he was going to feed the slaves they were using to harvest the sugar cane. He was going to feed them with grain that came from this country right here, what they referred to at the time as the Illinois country. And unfortunately, the whole exercise fell apart, that the yellow fever went right through his troops, the slaves revolted, his whole sugar empire fell apart. During this time when everything had fallen apart, one of the Spanish officials, a bureaucrat, closed down the United States from using the port of New Orleans to store goods until a seagoing ship could pick them up and take them where they were going to go. They called that the right of deposit. And they took away our right of deposit. So Jefferson sent a deposition to France to negotiate to buy the city of New Orleans so we would have the port. Well, Napoleon knew he could not possibly keep enough troops in the United States to protect it from everybody. So he said, instead of just the port of New Orleans, I'll sell you the whole of the Louisiana Territory for $15 million, which was a lot of money back then. And we didn't have any money. That's why we didn't have any colorful uniforms. Didn't even have money for dye. But the British loaned us the money. And you have to remember, this is only 25 years after the American Revolution. We didn't get along all that well with England, but England didn't want the French to have it. They didn't want the Spanish to have it. they were busy themselves fighting Napoleon, so they loaned us the $15 million to buy the Louisiana Territory. So when Lewis and Clark went forward into the Louisiana Territory, it was American territory. Lewis was in St. Louis for the formal proceedings of raising the flag. Lewis and Clark on the left here and Lewis on the right, they were co-captains on the trip, and they got along amazingly well. They started off their trip. One of their missions was to map from Camp du Bois all the way to the Pacific Ocean. Now this is like taking off for the moon without having any kind of map at all. They did have some mapping already available. More had gone on in the West than most people realized at the time as far as mapping was concerned. Alexander Mackenzie is a Canadian. He went from Montreal to the Pacific Ocean in 1796. And he wrote a book about it, which Lewis read very closely. Now, where he went through obviously was all in Canada. It wasn't in the United States. Also, just a few years before this, 1793, Captain Robert Gray discovered the mouth of the Columbia River. People had sailed right by the Columbia River and did not notice that there was a river there. But Captain Gray sailed into the estuary there and named the river after his ship, the Columbia. And so that's how the Columbia River got its name. And also, while he was there, he obviously took readings with his sextants to determine the exact position of the mouth of the Columbia. Also, there was an earlier expedition by Mackay and Evans. Mackay was obviously a Scotsman, and Evans was a Welshman, and they made maps going from St. Louis up to the Mandan village in North Dakota. So Lewis and Clark started off with a little bit of information on the maps. They copied all of Mackay and Evans' maps, and the French boatmen they hired, the engagés, a lot of them had been up and down the river quite often. But mapping was a prime consideration because with maps of the area, Jefferson felt this would give him justification for claiming the Western United States for the U.S. because we had been there and we'd mapped it. They were not dressed quite like this at the time. They were in uniforms like I'm in right now. To do the mapping, they needed to have the equipment of the day. And you'll notice Captain Clark here on the left is in his military uniform, and this is an officer's uniform. My uniform is that of a private. And Lewis was trained in navigation back in Philadelphia. You'll notice in this one that the red hair here, that means this drawing here happens to be of Clark. Clark was a redhead. He even carried an umbrella with him on the expedition, which was wiped away in a flash flood. But he carried all the cartographic equipment with him, even though they didn't have everything they could have used. It was a long trip. Here in the upper right-hand corner, this is an artificial horizon. This is a very important piece of equipment. This is the sextant. We can tell it's a sextant because it's over 120 degrees on this scale down here. But the most important piece of equipment, strangely, is this watch here. This watch is actually a chronometer, a very highly accurate watch that tells you what time it is in Greenwich, England. Also, they had compasses, and as they called them, spyglasses, telescopes. And this is Clark's original compass that went on the trip with them, at least a reproduction of it. You'll notice on this style that they have everything divided off into quadrants here, and the quadrants will come into importance a little later here. The other thing they had with them was nautical almanacs. And inside the nautical almanac, for the objects they were tracking, this would tell them exactly where it was, what point on the earth it was over. The basics of navigation are always, where am I and what is around me? Now, to determine our position on the planet Earth, we need at least two coordinates. One coordinate is latitude. That's the lines running parallel to the bottom of the slide, like a ladder. Just like rungs in a ladder, latitude is easy to determine. Our problem gets to be with longitude, the lines that run from the North Pole to the South Pole. With the latitude, we have three coordinates. If you go outside and you stand out there, if you start walking north, if you walk long enough, you're walking south. If you keep walking, you pass the equator. If you keep walking, you pass the South Pole. You have 3 points where you can definitively say exactly where you are. With longitude, you get out front out there and you turn west and you start walking. You walk west forever because there's no markers. Well, they found you had to designate a point out there to measure your longitude from. Well, everybody got in the act. The British obviously got in the act with Greenwich. Kyoto in Japan had a prime meridian. Peking had a prime meridian. Everybody had prime meridians. In fact, they even made a movie about one, the Paris meridian, the Rose line. They had a movie, The Da Vinci Code, which was all based on this Rose line, which the French don't keep a secret. There's little brass markers in the middle of sidewalks showing you where the Paris line is. Unfortunately, with so many of them, you couldn't tell what was going on, so they finally got together. The British were the power at the time, so the line that went through the British Observatory at Greenwich, England, was picked as the prime meridian, and everything is judged east and west from that point. Time equals angle. If we go back one slide here, you'll notice all of these circles are divided up into 360 degrees. That the Babylonians gave us the base 60s and 360 degrees in a circle, which worked out perfectly fine, actually. The whole world is divided up into 360 degrees. And the problem with longitude is that we have to be able to reference back to a point. With latitude, we've got the North Pole, the equator, and the South Pole to relate back to. But with the longitude, we only have a made-up line out there that everybody has agreed to. But we have to relate back to this, and the way we have to relate back to it is with time. If you stand outside for 24 hours, the sun goes completely around and comes back to overhead again. In the sun's course, doing that, it goes through 360 degrees. To divide that by 24 hours, the sun has to move at 15 degrees an hour. So this means if you get a longitude reading of 15 degrees, you are 1 hour away from Greenwich, England. So you can tell where you are. So time is equal to the angle. 30 degrees is 2 hours. And your chronometer, if it gets off by a little bit, which Lewis and Clark had some real problems with, you can reset the clocks by observing the moons of Jupiter. And this is the main reason they had the spyglasses, was to do the moons of Jupiter. Now, to get those angles, to get that 15, 30 degrees, whatever angle you happen to have, you need something to measure the angles. Back in the olden days, when I worked with a lot of fourth grade students doing programs, we would have a program where we worked on angles and degrees. And we would make what I refer to as a Porter's quadrant, which has 90 degrees in it. This is nothing but cardboard they learn to use their protractor to put on. All you really need is 90 degrees. You don't need the whole set here. You just need 90 degrees. And then on top of that, you glue an astronomical sighting device. Strangely, the Subway sandwich shop gives away these astronomical sighting devices. They actually use them to drink their sodas and such. They're just a common straw. And then you put a hole in your cardboard, you hang a string from it with a heavy weight of some kind. That heavy weight will always point to the center of the earth given the chance. So if you go out at night and you look through one end of the straw at the star Polaris, this will give you your latitude. I'll draw a little diagram in a minute here to show you that. Just an easy way to get your latitude. Also on this slide, you'll notice in the upper left is a sextant, and a sextant has a scale of at least 120 degrees on this curved bar on the bottom, and an octant, which has at least 90 degrees. So this is a quarter of a circle with at least 90. One important mathematical calculation, which is well known to fourth graders, is corresponding angles. And this is important in our evaluations here, that if you have two parallel lines and you traverse them with another straight line, the angles they formed are matching. You'll notice here that the two red angles, number 1 and number 5, these two angles are exactly the same. 3 and 7 are exactly the same. All of them are equal, and they're called corresponding angles. Fourth graders pick right up on this. They jump on that topic right there. A sextant is basically a fancy device for measuring angles. You'll notice it has two mirrors on it, and the mirror on the bottom down here was normally a half mirror, to where you look through your eyepiece and half the mirror you can see the horizon. The other half the mirror you see the picture coming from the sun or star, whatever you're observing up here, and you move it back and forth with this scale here, and this will tell you the angle between the astronomical object and the horizon. And this is the picture in the upper right that you would see looking through the scope here. On the right-hand side, you're going to see the sun. The left-hand side, the horizon. You move this back and forth until the sun comes down and the bottom limb just barely hits the horizon. Then you take a reading on here. In using a sextant was obviously originally set up to be used on the ocean. In the upper left-hand picture here, you can see the little boat here, and you get the angle between the horizon and where the astronomical object is. The dip that's referred to here is the distance you are above the horizon, 6 feet plus the height of the boat, whatever it is. And you have to bring that into the calculation because that will change the angle. On land, you can see from the picture on the right, you don't have a horizon. Your horizon isn't flat, it's mountains, it's whatever's out there. So we have to use an artificial horizon, such as in the lower left here. You have to use an artificial horizon. Lewis and Clark had 3 different artificial horizons depending on the lighting conditions. But you can see from the drawing on the right that the light from the sun comes in, and there is a fluid, usually water, in this, and the artificial horizon not only has sunshades on it, but it keeps the wind from ruffling the surface of the water. Later explorers like Zebulon Pike used mercury, which is pretty heavy all in itself, so it doesn't get wrinkles on it, and you can just use a bowl of it if you want. As an expedient in the field, you can take a pan full of water and use it. I often use the bird bath in the backyard as a reflecting surface. I live in the Ozarks, so I've got to shoot over the trees. The only problem with doing it this way is you end up doubling the angle when you do this, and so you have to divide by 2. All 4th graders can divide by 2. They're very good at that. 4th graders are more amazing than you think at times. Now, Polaris, on the far right in this picture, labeled as Polaris, the North Star, is important because it only varies a half a degree on either side of being exactly on the North Pole. Back in the times of Lewis and Clark, they used this little dipper as a clock. If you look right down here on the lower left where it says Beta Cocab, that's Cocab. That these other stars, now back in those days, before we had all our light pollution, they didn't show up as well as they could, but you could still see them. Nowadays, you sometimes lose most of these stars, but you can usually still see Cocab unless you're too close to St. Louis. And then there is a problem with the light pollution. But everything here, amazingly, moves at 15 degrees an hour. So if you're on a night watch, and privates like myself wouldn't have had a watch, and you're supposed to be relieved at midnight, how do you know when it's time to wake up your relief? Well, you know by watching this Cocab. It, amazingly, moves at 15 degrees an hour, just like the sun, just like everything outside of the Earth, except our own solar system, moves at 15 degrees an hour. Now this is a quadrant. You can see it has a straw on the top and a weight, and the degrees marked across the bottom. At night you can take this out and cite Polaris and pinch it there or have someone else read it, and it will tell you, in this case, it would set right there at about 38 degrees. And that's our latitude right here. And just in case someone ever asks you exactly what's going on there, that if Polaris is up here, okay, all the light coming from Polaris is parallel. It's so far away, it's parallel, so the light from Polaris, the North Star, would just come right through the Earth like that. Okay? Now, if we are right here, we draw a line through here, this is our zenith. This is straight up. This is the horizon. Now, right there where those two lines cross, that's 90 degrees. Okay, so we know that's 90 degrees. We also have the light from Polaris parallel to this line coming through that point. We take our angle measure, which can be a simple piece of cardboard or a sextant or an octant, whatever you've got. All we're measuring is just the angle. This takes no spherical trigonometry. This is simple. We measure this distance, this angle right here, which we call height, and that is the height, angular height of Polaris. We refer to this as the co-height. And we know from that being 90 degrees that co-height plus height equals 90 degrees. So we can always keep that straight. That if we look, what we're after here is our geographic latitude. And we look over here at what angles we've got. We can tell to get this, it's the same as this angle here. In fact, it is that angle there. Okay. If we look up here, where is that angle again? It's right here. So this is the co-height here. And the co-height plus the height equals your geographic latitude. And so this has been determined by ancient mariners for a long time. They could always measure their latitude. Now, Lewis and Clark, in order to establish their points, used the noon sight. Now, the noon sight sounds like it would be very complicated, but it's not. We start off with the same Earth here, and we're just going to start off with part of it. We don't need the whole thing. We have the equator here. We have north and south. We're over here. There's our horizon. And there's our zenith. Now, what this is going to give us is our longitude. The sunshine okay, we can draw the sun to sign parallel just like Polaris. So far away, it's all the same when it gets here. But again, we take our angle measuring machine, sextant, octant, whatever, and we can get this distance here. And what we do is we start off and we go out and we take one measurement with this angle and note the time it is in Greenwich. Okay, we take another angle and the angle has increased. Take another angle and the angle has increased. Take an angle and the angle has decreased. This point here is noon. The sun is at its highest point right there. And so we take a look at the time for that. Over here, with the space we've got right here, this height of the sun above the equator is known as declination. Declination is, you can get out of your almanac, or you can get out of, if you just think about things a little bit. In 2 days, we're going to reach the summer solstice. The summer solstice is 23.5 degrees, which is the tilt of the Earth. Then after Saturday, the sun's going to start going down. So to get our geographic latitude, okay, we have the declination, this distance here, then we have this distance here. So we have to look up here to get our, what this distance is, and the distance is the height. So our geographic latitude is this distance plus this distance. Because here's the parallel lines, here's the intercepting line. So the co-heights here and the declination add up to the geographical latitude. And what this will do is it will give us a point on a map. Now we're going to go back to the slides and talk about the compass a little bit. Compasses on the trip were really very important. They not only just point north, but they give you a reference. First, you have to have a point where you know exactly where you are on the Earth, latitude and longitude. And we can see with the noon sight, and they had 9 stars that they tracked to determine their latitude and longitude, so they knew the point at which they were. But points don't make maps. What helps make maps back then was the compass. Now, compasses came wandering in from China rather late, and by 1700, they had determined that they had a real little quirk to them. Compasses point north, but they point toward magnetic north. And sometimes, as you can see, by a large amount. And with compasses, they talk about that as declination, but navigators always use the term variation, because declination, as you can see from the previous section, declination is used for the height of celestial bodies above or below the equator. So Lewis and Clark had to compensate for the magnetic declination. And from the previous map, you can see this is a declination map fairly recently here. You can see over here where it says 0. 0 is right next to St. Louis. This is called the agonic line. The compass needle points to the magnetic and geographic pole. Unfortunately, things are moving a little quicker now than they used to. But Lewis and Clark had to account for that. And one of the ways of doing this, and the most simple, is by using Polaris. Polaris is just about due north. So at night, if you get your compass out and see what direction it's pointing, and then compare that to where Polaris is, the angular difference between the two is your declination. This little line right here, that shows the declination, the distance between the two readings, and what you have to add to or subtract from your compass reading. And so this will help keep us track of what direction north is, which you'll see in just a minute is very important for the map making part of this. Now, just as a point, the magnetic North Pole moves. And in fact, you can see from this table here that in the past it's just been kind of moving slowly up toward the date line. And then suddenly here, just recently, it's really jumped up. Some scientists think we might be getting to the point where we're going to reverse poles again, where the North Pole will become the South Pole. It's happened before, so it's not like it's something that anybody's going to panic over. Well, let me take that back. Somebody might panic over it, but it's just going to flip your compass over. But Lewis and Clark used the compass in their map making. It's a system called compass transverse mapping. In the journals, you'll notice quite often Clark will have a section in there about where they went for that day. And this is the form in which he would put it in there. He would note the miles, how far each section was, and he would report the direction in a way today we consider unusual. He would put south or north if it was due north or due south, but if it was at an angle to north or south, he would say south 28 degrees to the west, okay, south 10 degrees to the east. And he would always state in there some type of landmark he could use to check it if he had to. They did a lot of backsighting. Once they had gotten to a certain point, they would shoot back the other direction to check their readings. Where it says starboard here, this is the right side of the vessel. If you look at the Bordeaux tapestry and other paintings and drawings from the Middle Ages, you'll notice the steering board is on the right. And that's what this is. Starboard, steering board is the right side of the boat. Larboard, in this case, is the left side, and larboard is now known as port, because this is the side of the boat that you put up next to the dock, because if you put up the right side against the dock, you'll break the steering board, which is just hanging over the edge. Okay, Clark, at night, he would sit around the campfire and draw small maps. And he made many of these small maps for every day. He would take those readings he had recorded, and as the river went down this way, he had gone from here to here 1.5 miles, and on the larboard side there was a rock like a tower. This distance here, they were using graph paper so he could scale that out. And the direction of this, the first one he said it was south, just pure south. The next reading, we're going to go 2 miles, and our compass reading to get down here to a pile of bushes was 2 miles, and our compass reading was south, and it would be, let's see, 20 degrees west. And here at this point of land, river comes around this way, and the compass reading is south 20 degrees east. Whoop. I made a slight mistake here. It wasn't west, that's coming back east. And this is west. Clark would draw this up, and he would have the miles in here, okay? And every day they traveled someplace that he could, he would make up little maps like this. Then at Fort Mandan and at Fort Clatsop, he would put all of these little maps together into a bigger map. And so this is a very simple system, but you can see he's really dependent upon his compass readings. And so it was important to keep those compasses working fine. So he uses the latitude and longitude to get a physical point. And then he can, from this map, over here in this direction is a huge mountain. Now, he might not know how far away that mountain is, but from here he can get a reading of what's his compass direction. Where is this mountain? Then he can draw that mountain on there, even though he's a little unsure of what this distance is. He's not sure. But he would draw up all of these little maps like this. And they would also, as you'll see in just a minute, they would use maps from Indians and from everybody else. This is actual types of equipment that Lewis and Clark would have had on the trip. Obviously, the rifle I talked to you about earlier, which was high-tech for the time. It was, a much shorter barreled rifle than was common in the day. This is the sextant. You'll notice with the sextant, this arm has a release down here that moves the arm back and forth. And if you watch this mirror up here, that mirror moves back and forth. And all this does is the very same thing this piece of cardboard a fourth grader made does. It measures angles. And it doesn't just measure horizontal angles. If you hold this on its side, you can measure the angular difference between two mountain peaks or anything else that's out there that you're looking at that you need angles on. You can get it with this. This works too. All we're getting in navigation is angles. But this is the basic piece of equipment. It has sunshades on it that, particularly when taking noon sights, we have a real problem. Back in the olden days, they had a condition called navigator's eye. Navigators would gradually go blind in their right eye. No matter how many of these shades you put down, no matter how dark you made it, it impacted your right eye, and navigators would soon lose their ability to see out of that eye. Nowadays, we don't have that problem, but back then, that was a real problem with navigators. We have much better sunshades today. But this is your prime piece of equipment, is your sextant. It gives you angles. The other big piece of equipment is a chronometer. A chronometer is nothing but a very, very fancy watch. In fact, this was the most expensive piece of equipment on the trip. $250 and 75 cents for the key to wind it, which Lewis and Clark did not always remember to do. This is important, and this had the time in Greenwich, England, not here. This is what you use to get noon here. Like I did in the diagrams earlier, you keep taking readings as the sun goes up and up and up and up and up, and when the angle comes down, you know you've been through noon. So someone has had to be there during each of these sightings to write this down. The angle and the time. And you always write the time down first because the angle is recorded right here. So you can always get that, but the time, your watch keeps right on going, so you need to put the time down first. This is an artificial horizon. It's a very simple piece of equipment. Lewis and Clark, as I mentioned before, had 3 of these. You would normally put water in them, and the little container like this is to keep the wind from ruffling the surface of the water. If you try to sight through the water going up and down or rippling back and forth, you can't get your readings correctly. So this keeps the wind off the water. If you need extra help with the brightness of the subject, you have pieces on there that are also sunshades. Now, like I say, Zebulon Pike used mercury, Lewis and Clark used water, but this is the artificial horizon, which was a very important piece of equipment to them. This is a reproduction of the Elkskin Journal, which they made on the trip. This is what they recorded the information in. The information is no good if you don't get it written down. You write down everything, which was a little confusing to some of the later people going through Lewis and Clark notes. They recorded everything. So they have tons of stuff, not just a series of booklets, but many booklets, pieces of paper, and everything else. The very important piece of equipment on the trip, the compass, and this is a reproduction of Lewis's compass. You will notice on the compass that it doesn't have 360 degrees around the edge of the compass here. From north and south, they have the numbers going up from both directions rather than just a series going around with 360 degrees. They're designed for the transverse mapping. And so when Clark went out there, he knew that this is what he was going to do. So this is the type of compass he used. Obviously, this is not the real one, but they do have the real one in a museum. This is the Class A cover. None of them survived the trip. This cover here, this is the fatigue cap, made in the French style out of your old uniform trousers. So these were their two hats. And this one is meant to kind of scare people off a little bit. You know, without my cover on, I look meek and mild-mannered. But when I put this on, suddenly I'm taller and meaner, and hopefully everybody will leave the field of battle because I scare them off with my hat, I would hope. And that's the equipment that they carried on the trip. Lewis and Clark, when they first started out, they knew where they were and they knew where they were going, but they didn't know what was in between. When we went to the moon, we knew exactly what was between us and the moon, and we had everything down to an exact science of exactly what was going to go on when. Lewis and Clark knew the latitude and longitude of Camp du Bois, so they knew where they were starting. They knew the latitude and longitude of the mouth of the Columbia River, thanks to Robert Gray and later explorations by Vancouver, so they knew basically where they were going. They had maps that went up to North Dakota, thanks to Mackey and Evans. But even the Native Americans really couldn't help them much on the big bend in the Missouri River up here at the top. When the Mandans would go raiding out west to capture other Indians and cause general mayhem, they didn't go by river. They went by horseback straight across from the Mandan village to the area around the Yellowstone and the Idaho area, all in through there. So when Lewis and Clark asked them about the river up here, the Indians really couldn't tell them anything because they didn't go up that way. Part of the reason they didn't go up that way was because the Blackfeet were up here. And the Blackfeet were kind of like the Comanche. You just didn't want to push them any, or the Pawnee for that matter. So they knew pretty much the first part of the route, but the rest of the route, they had no idea. The Rocky Mountains, they were thinking of them more in line with the Appalachian Mountains. And they thought the Rocky Mountains were only one range. And so the first time they got a look at the Rocky Mountains, they were shocked. The Native Americans didn't even cross over them very often because, unfortunately, where Lewis and Clark chose to cross through the Bitterroots is probably the hardest place in the whole Rocky Mountains from California to Canada that you could cross. But they did have that information, so they knew about where they had to go and how far, but they had no idea of what was there. As they went along with their maps, they put notations on them for all kinds of things to match their notes in the journals. Is the soil good? Is the soil not good? Here it talks about short narrows, where you're going to have trouble navigating with a vessel. They recorded all the information they possibly could. And they recorded them in these small maps using this compass transverse method that, to make the smaller maps to put together into the larger maps. This is a map of the falls of the Missouri. They're all covered up now by dams and such, but that's their original drawing of the falls of the Missouri. But they also used information from Indian groups. This map here is of the Columbia River Basin, and it notes the tribes along the river. This is a map by Sitting Rabbit. He was a Mandan. You can see that the Indians, when they worked on maps, they used lots of pictures. This picture up here at the top is not an airplane. It's crossed snowshoes. You have to remember, when Lewis and Clark were going through here, this was at the end of the Little Ice Age. It was much colder through here at that time than it is today. So they have crossed snowshoes up here, but you can see all kinds of little drawings of things all over the Indian maps. On the way back from the trip, they retracked all their calculations. Clark dropped down to the Yellowstone River and went that way to get more information and to see if it was a better route. Actually, any route other than the one they took through the Bitterroots was a better route. And they'd been gone so long, 2.5 years, they met trappers coming up the river. And their mapping and their exploration, and particularly them telling everybody of all the resources they had found out there, all the beaver and everything, they were the start of the manifest destiny. They provided the information and the impetus to settle the western United States.